Hello, my name is Sylvie Trudel, and on behalf of the Cosmic Group, I'll be presenting to you today Module 4 of our collection of videos, which is the real-time case study overview. In this Module 4, you will see an overview of real-time case studies. You can check out our other module, for which the topics are Module 1, Why and When Measure Functional Size, Module 2, Cosmic Key Concepts and Definition, Module 3, Management Information System Case Study Overview, Module 5, Cosmic Non-Functional Requirements, Module 6, Early Sizing Overview, and Module 7, the Estimation Process. Now, the Cosmic Measurement Manual comes in different parts. Part 1, Principle Definition and Rules. Part 2, Guidelines to implement these described in Part 1. And Part 3, Examples of Cosmic Concept and Measurement, consisting of Part 3a, Standard Measurement Strategy Examples, Part 3b, Real-Time Examples, and Part 3c, MIS Examples. Now, this presentation is about the real-time examples. Let's look at standard strategy for whole real-time application. Now, the standard strategy should be used when the need is to size of a typically large-scale real-time application seen as a whole with hardware devices and other interfacing software as its functional user. In this case, we have here the real-time application. On this side, the intelligent functional users, such as intelligent hardware devices, operator workstation, and other interfacing application software. On the other side, we've put the dumb hardware input devices. Those are sensors, button, clock. They only send a signal. And the dumb hardware output devices like actuator, lamps, alarm displays, and it could be also valves, heater. They only receive a signal to turn on or turn off. Now, the real-time application interfacing with many possible types of functional users, dumb and intelligent, are shown here. And don't forget, it can also interface with interfacing software. Now, standard strategy for operator workstation of real-time application. In such case, such workstation application are typically needed to enable an operator to start and stop the application, control the configuration, set parameters, collect statistics, etc. of real-time systems such as telecom network, major process control system, and the like. Now, this context diagram is essentially the same as that for an online business application. Let's look at infrastructure software with an example of reusable software. Infrastructure software has example with loads of reusable software and device driver software. The following is showing an example of the reusable software, where you've got your software here and it interacts with other software component or application. Now we're talking here reusable component. It could be services or microservices as well, and any other reusable component. Now these are called minor component, usually at the lowest level of decomposition, meaning that these are minor components that usually cannot be decomposed any further. Let's look at something more complex. The example of real-time functional process of a chemical factory, where this process, the PLC software, it consists of filling a tank with a liquid, heating the liquid, and then emptying the tank when a temperature is reached that is preset in the temperature sensor device. So let's look at the requirements first. So the process is started by a human operator pressing the start button. connected to the PLC software, which controls all the subsequent steps. Now, the software issues a command to open the inlet valve of the tank, and the tank fills with liquid under gravity. When the tank is full, the high level reach is detected by the high level sensor. The software receives a message from this sensor and sends a command to close the inlet valve and start the heater to heat the liquid. When the software is informed that the preset temperature is reached with the temperature sensor, it sends a command to stop the heater and then open the outlet valve and start the pump to empty the tank. The pump continues emptying the tank until low level is reached, detected by the low level sensor. During the entire process, the process status such as filling, heating, and pumping is shown on the display of the operator. And when the process is finished, the software causes an audible alarm to sound, and the message process finish is shown on the display. So the alarm goes on. And then when the process is started and while the process is running, the PLC software pulls the valves, the heater, and the pump, asking for their status at regular intervals to detect any fault conditions. If the PLC software is informed that an error is detected, it starts the audible alarm and displays a message to the operator showing the device concerns, could be more than one. If an operator receives such an error message, then it deals with it manually outside the software system. The polling frequency is determined by a signal or ticks from the clock in the timer. Now, let's look at the triggering events of that system. Well, first there's the start button that is pushed. So the human user will interact with the system pushing the start button, and the corresponding functional process is start process fill the tank. There's high level reached through the high level sensor, and then is to heat the liquid. There's the preset temperature that is reached through the temperature sensor. It will start the process, stop heating empty tank. When low level is reached with the low level sensor, we start the process, finish process, and the clock tick, time to poll with the clock or timer, if you call it timer. There's the fault check that is done. So there are 5 triggering events related to this previous diagram. We will then identify 5 functional processes in this case. So let's look at the detail for the functional process, start the process, fill up the tank. We will show only this one process, and its size is 4 cosmic function points. So on the entry of the start button, the start process message is received by the software. So it's input, therefore it's an entry. Then we send a command to open the inlet valve. We start the clock for fault detection at regular intervals. And then we display the status filling. So 1 and 3 exits. Also, the other functional processes are heat the liquid, 4 cosmic function point, stop heating empty tank, 5 cosmic function point, finish the process, 6 cosmic function point, and fault check, 7 cosmic function points. So in total, this system or software is of 26 cosmic function point. And for further detail, please refer to part 3B of the real-time example, page 17 and over. Let's look at the intruder alarm system context diagram. Now, we have a keypad, power voltage detector, front door sensor, movement detector, the software. It has persistent storage, and then output devices are external alarm, internal alarm, and two LEDs. Now, there is only one triggering event for this case, and that will be the front door sensor. Now, let's look at the data movements. Well, first of all, the front door sensor sends a signal when the doors open. It will go read the occupant pin from persistent storage. Then the green LED is switched off and the red LED is switched on. So we've got two different exits here. And the internal siren starts noise. Beep, beep, beep. On the keypad, the user enters its PIN. Now, if the wrong code is entered, the user may enter the PIN 2 more times, but the process is always the same, so it is only measured once. And then if the successful PIN is entered, the green LED will be switched on and the red LED will be switched off. The internal siren will stop doing noise. But the external siren can start noise command after 3 unsuccessful PIN entries or if the PIN is not entered in time. What does that mean in time? Well, after 20 minutes, well, it's not only 20 minutes, but that time has to be defined and coded. So it's a constant. Then after 20 minutes that the alarm has went on, it needs to be stopped. And this is a legal requirement. That means that, and it could be different in every city, but let's say that in this particular town, after 20 minutes that an alarm, let's say a burglar alarm went on, it needs to stop. Then a timer must be used to stop the external siren after 20 minutes. So in this case, the number of cosmic function point is 8 because the green LED and the red LED are repeated occurrence of exits. Therefore, these objects of interest will be associated with the same movement. So in conclusion, Cosmic Measurement Manual Part 3B Real-Time Examples provide more examples also in its section 3 that is available at this address, cosmicsizing.org, publication, Measurement Manual version 5.0, Part 3B Real-Time Examples, where there is PLC software for controlling a process in a chemical factory, measurement of a change to the PLC software, timing functionality, intruder alarm system, cooker software, tire pressure monitoring system, automation of sizing real-time requirements, measurement of data manipulation-rich real-time software, and sizing the memory requirements of vehicle electronic control units. I hope you enjoyed and thank you all. See you in Module 5.